Good afternoon. Thank you very much for coming. And so today we will have a AIP progress meeting, a progress report meeting series named Impact of Conversations on Cognitive Functions. And so served by Cognitive Behavior Assistive Technology team. And this is Mihoko Otake-Matsuura, the team director of the team. Before starting, I will describe briefly about the rules of this. And here are some important notices about this meeting. Reproduction is prohibited, and reproducing all or any part of the contents is prohibited without the author's permission. And the meeting will be recorded, and the video will be available in the RIKEN AIP website later. And if you have any questions or comments, please scroll to the bottom on the page and click the Q&A button, Q&A tab. This is for online participants. And we have also a YouTube channel and Twitter, so please follow us. Today's schedule, Professor Hiroko Dochi from Harvard University will give a talk about the internet-based conversation engagement trial named I-CONECT, and theoretical framework and latest findings. And so Professor Hiroko Dochi is a professor of neurology at Harvard Medical School and director of research analytics at the Interdisciplinary Brain Center and Department of Neurology at Massachusetts General Hospital in Boston, Massachusetts. And so I got to know her from her publication of the one of the first paper on conversational intervention trial. And so when we started our study on conversational intervention, and so it was really hard to find existing works. And so finally we found her work. And then so since then, I really would like to get to know her and to have a talk. And so during COVID time, once she visited us, but it was COVID time, so it was very difficult or hard to get together. But now we can invite her to give a talk and to and share her latest findings and her perspective and how we can make our society much better. So where people can live well happily and with well-being. So whether people are well with cognitive functioning, and so that they can maintain our functioning until the very end of life. And so after that, I will have a talk about a robot moderating group conversation for cognitive intervention to healthy older adults. And then after that, we will have a coffee break. And then we may have a dialogue with Hiroko and me. And so about impact of conversation on cognitive functions. And I will briefly introduce what is RIKEN AIP. So RIKEN founded Center for Advanced Intelligence Project, AIP, in 2016. And then so it was settled as a 10-year project. And actually, this is the final year of this original plan of the project. And then it's located in central of Tokyo. And then in that, we have started up a cognitive behavior assistive technology team in the AIP Center in 2017. Because AI nurturing or complementing intelligence of human are becoming much more important than ever before. So artificial intelligence performance improves, and so recently humans really rely on some intelligent and intellectual activities. And so we need to, but at the same time, we can improve our intelligence by using the AI as well. And cognitive behavior assistive technology team puts emphasis on developing cognitive behavior assistive technology, which promotes cognitive reserve for prevention of cognitive decline and dementia of older adults, which damage the intelligence of human necessary for social life. And so we aim for AI for super aged society. And so we are, so these are the members of our team, and really diverse ages from 20s to 80s, and so females 33%, and so countries are from Poland, Canada, Thailand, China, and Japan. And so our goal is to realize society without which prevent dementia. And in order to realize, we develop cognitive behavior assistive technology. And in particular, development of conversational assistive technology based on co-imagination methods is our focus. And in order to establish effective intervention and to make clear the evaluation criteria where AI has good effects on human, this is the motivation of our study. And so in order to do this, we have 3 subgroups. One is to develop conversation support system, and then another group develop analysis method, and then so another group develop evaluation technology of the, we evaluate the effects of the developed system. And among these researchers and many practitioners, and then we are successfully collecting data and also developing analysis method as well as the systems. And now, so as I first mentioned, this is the final year for the first 10-year project. And so, so each team is holding progress report meeting to show the research achievements to society. So among these series of progress report meetings, today we will have a meeting on cognitive impact, so impact of conversation on cognitive function for today. And so this is a final year, as I mentioned, and also the last year was the final year of the midterm, mid to long-term RIKEN, 7-year plan. And it started in 2018 and 24. And then along that line, so there are 3 groups in AIP. And we are in the group of goal-oriented technology research group. We tackle with the social impact on aging world, dementia. And we envision society which prevents dementia. And there are other 2 groups, and one is generic technology research group working on fundamental technology of AI, and another group working on artificial intelligence in society. So they are working on. And so along these 3 groups, we are tackle with the next generation AI. And so since 2025 fiscal year, from this year, RIKEN is a 5th mid to long-term so a plan. And then so our next AIP group is organized as shown. And so one was domain intelligence. It used to be goal-oriented research. And then another is mathematical intelligence, and it used to be a fundamental research for AI. And so new one is a physical intelligence group. And so namely, they are working on robotics, and so to study real-world problem solving using AI. And so this is a new organization. And so we are now we work, so our work is positioned as domain intelligence, and especially for cognitive and social intervention technology. So this is the introduction and background of this seminar. And then so we may switch to Professor Hiroko Dust's talk. Thank you very much.
Thank you. Okay, so I'm Hiroko Dutch from Harvard Medical School. And thank you so much, Mihoko, for inviting me to give this talk today. We have so much common interest using a conversation as a tools to stimulate our brain. So I'm so happy that we can collaborate in many ways. The outline. So first, probably everybody know in this stream, everybody knows how important it is to improve social engagement. But in any case, I just briefly go over the relation between social engagement and cognition, what is known, especially in epidemiological studies. And then theoretical framework for clinical trials, which we used, and then introduce some of the results from our project. Okay, so humans are social creatures. The link between social isolation and adverse health outcomes has been well documented over almost 5 decades in the gerontological field. As for the link between isolation and cognitive impairment, many epidemiological studies have shown that larger social network and the higher level of social engagements are protective against risk of developing dementia. So here are some of the meta-analysis. Now we are almost in an age when we can do the meta-analysis of meta-analysis. There are many studies in this area, especially in gerontology. So here one of the published relatively old 2018 by Australian group, and they used 31 cohort and 2 case control studies, and they showed that having a poor social network increased the hazard rate about 1.59, meaning that if they have a poor social network, 59% higher than others to get to dementia later on. And then also social support, poor social support hazard ratio was 1.28. So this meta-analysis showed that social engagement is very important. And then another one, this is about the same time, 2019. This study was done by British group, Carol Brain and Linda Clare, and they also showed about the same rate, about same hazard rate, showing that social isolation is a risk factor, larger social network is a protective factor. So this is actually one of my studies. I collaborated with University of Hawaii. You might know the Honolulu Heart Program. Honolulu Heart Program started really all the time. This is a study which is well known for, even though genetic is the same, lifestyle factor is very important. So Honolulu Heart Program is the one which compared the Japanese living in Japan, and then Japanese living in Hawaii, and then Japanese who live in US. So genetically, they are very similar, but lifestyle changes. And then once they immigrate from Japan to US, they are more likely to have a heart attack, cholesterol, high cholesterol, and all because of the diet and then car-based society. They don't walk so much, they just use car. So even given the same genetic, lifestyle can affect our health a lot. And that was about the 1960s, 1970s. So Honolulu Heart Program was a very long-lasting study. And then around 1980s, they studied the Honolulu Asia Aging Study, which is targeting dementia study. And using that long-lasting study, we checked whether poor social network or smaller social network is associated with dementia risk. And we had about 2,600 people in the cohort. And we found that weak network measured by Rubin's social network scale predicted increased incidence of all-cause dementia with hazard rate of 1.52, meaning that if you have weak network, then 52% higher likelihood, higher risk of getting all-cause dementia. And interestingly, this study shows that Alzheimer's disease risk is actually higher than all-cause dementia. So the hazard rate was 1.67. So somehow social network lead to Alzheimer's disease more than vascular disease. So that was an interesting finding. And then we also deleted people who remained dementia-free during the, we only selected those who remained dementia-free during the first 3 years of follow-up because of reverse causation. If you are already almost getting dementia, they might reduce their social networks because of disease. So we deleted these 3-year frameworks, those who are developed dementia within 3 years to avoid reverse causation, but we still find this results. So, and the most, and this one is also 2022 and published in Neurology. Now, gerontology, there are many articles about social network and cognition, but neurology, not so much. So this is almost the first big study which neurology, Journal of Neurology, focused on social interactions. So it's a very critical step for our study, I think. And this one used British data set, UK Biobank data. That's a big one. And then what they found was social isolation was associated with a 1.26-fold increased risk of dementia, independently of various risk factors, including loneliness and depression. So they also found this risk. And then this is a huge study. It's very robust. And they also found that socially isolated individuals had lower gray matter volumes in temporal, frontal, and other regions. And then they also checked the mediation, they conducted mediation analysis, like how much of the small brain explain the risk of getting dementia later on. And they explained only partly. So the small brain, you know, I shouldn't say small brain, but small gray matter volume is sort of associated with social isolation, but that small brain does not necessarily explain all the risk. So that's this one's finding. And I'm very pleased that neurology published this because so far neurology did not pay attention social isolation or social factors much. So this was one big stepstone for us. Now, Lancet commissions have been publishing the report like this, like what explained the dementia risk. So the most recent one was published 2024, and then they estimated that here 5% of dementia cases can be prevented by eliminating social isolation, which is larger than 2% estimated for physical inactivity and smoking and diabetes. So this is another big study. Now, here you can see hearing loss. Regarding the midlife hearing loss, high LDL cholesterol, depression, these are the big risk factors. But when they get older, social isolation and air pollution, and this kind of factors play a big role. Okay, so one of the estimate done by National Academy of Science, Engineer, and Medicine, they think 1/4 of community dwelling Americans age 65 and older are considered to be socially isolated. Now, I don't know the Japan's case, but US social isolation is a big issue, societal issue. Okay, so as for the potential mechanisms for the link between social isolation and cognitive function, one widely accepted theory is that stimulation from social interactions could enhance cognitive reserve. So Mihoko also mentioned about cognitive reserve. For example, several studies have shown that given the same level of disease burden, those with a high social network can do better. So symptom does not show up much. So I can introduce one of the example. So this one was done by 2006 by Rush Memory and Aging Project. And so we know there is a high correlation between autopsy, tau level, tau accumulation at autopsy can be related with cognition. So the higher the tau, the lower the cognition, like this. However, if you have a high social network, this is a level, at the level of relation between tau and then cognition can be attenuated significantly, like flat. If you have a high social network, you can reduce the clinical symptom coming from high tau by considerable degree. So this is the association between tau and then cognition among low social network group. And then this is high social network group. So because we believe high social network people has larger cognitive reserve. So I just want to tell you, so Jacob Stam is the one who first mentioned cognitive reserve. And it's also very similar with scaffolding theory proposed by Dennis Park. So the dementia, as you may know, pathological burden, which is mostly common, tau and amyloid are the two main hallmark for Alzheimer's disease. But this pathological burden is not necessarily related to clinical symptoms. So this is a very unique aspect of dementia, because if you know heart attack, you have a heart attack or cancer, the tumor, if the tumor is large or spread, then you are more likely to die. But in dementia, it's not clear cut. Even though who has a lots of pathological burden, they are not necessarily show the symptoms. And then even the small pathological burden, some people show lots of symptoms like memory, forgetfulness, all this. So why this is the case? And this is called a cognitive reserve. It's just like a computer. Even one part is affected by virus. If you have lots of good network, then you can compensate for that loss by other functions. So that's the basic idea of a cognitive reserve. And then scaffolding theory, it's very similar. So scaffolding theory was proposed by Dennis Park. And as you can see, there is a functional deterioration, neural changes, but if you have compensatory scaffolding, scaffolding is like platform steers, that's the scaffolding. So if you have a very solid system, you can compensate all these damages so symptom does not show up. And then here, they say scaffolding enhancement, the factors which enhance solid scaffolding is new learning new things, social engagement, and exercise, and then cognitive training. Now they revised this a little bit more in 2014, and they added more things, but basically it remains the first paragraph, first flow proposed by Dennis Park. Now they added some more like amyloid tau, like dopamine activity, and then brain thickness, brain volume as a brain structure aspect, and then brain function, neural specificity, and then activity, dorsal network, and then basically brain connections. So these will be changed by stressors. But if you have intervention, including social engagement, exercise, new learning, or compensatory factors, then the symptoms can be much suppressed. So even though you have a lots of bad pathology, if you have a big protective factor, cognitive reserve, then you might be okay. There's no symptoms. Okay, so there are many accumulating evidence in epidemiological studies. And then also there's a potential theories such as scaffolding and cognitive reserve. But there are not many randomized controlled trials that use social interactions as a tool to enhance cognitive function and delay the onset of dementia, as you know. We are the very few studies, Mihoko's study and my study, there are very few studies to use actually social conversation as a tools to enhance cognitive reserve. And then also underlying biological mechanisms are not well known. So therefore, in 2010, I and my team developed a randomized controlled trial that used conversational interactions as a tool to enhance cognitive functions, targeting the oldest old, or I should say older old. Now, why older old? Because the older old is the fastest growing segment of the population worldwide, yet they are often excluded from clinical trials. Slowing the cognitive decline among this age group for even a few years could have a significant impact on the overall prevalence and incidence of dementia. So our goal was to develop an intervention that is easy to start, even among those without much motivation, can be done at home, and the engagement is sustainable for the longer time. This idea led to the first pilot project trial we used in 2010. So we conducted a first small pilot in 2010, funded by NIH, and then followed by next two trials. One is targeting those with normal cognition, and then another one, MCI. And these latter two is called the I-CONECT project. And it was completed in 2022, about 3 years ago. So here is our version of a hypothesis behind this clinical trials. So social engagement is very, very multifactorial. There are many people who ask me why I don't combine social engagement with exercise, nutrition, all this, because that time, like finger trial. How many of you have knows a finger trial? Yeah, so it's a multifactorial lifestyle change. Many, many components is combined, but we wanted to do the social engagement specifically targeted trial because social engagement is already multifactorial. As you can see, social engagement has two parts. One is like social isolation, for example, lead to, or not socially isolated, lead to tangible factors, enhance tangible factors. You have someone can take you to the hospital when you are sick or do some household chores for you. So that's ultimately leading to brain health because you can reduce the chance of infection, reduce the chance of disease getting worse. So this can be support, especially support system. That's a tangible effect. But there is non-tangible effect, intangible factors, which is basically emotional well-being and cognitive stimulation. And for I-CONECT study, we wanted to focus on this part. We wanted to focus on cognitive stimulation and how cognitive stimulation coming from conversation can affect compensatory neuroplasticity, meaning that brain network and then brain functions measured by functional fMRI and volumetric volume MRI. And then that might lead to health. So that's we wanted to check. Now, Mihoko asked me earlier, what's my next stage? So next stage, we want to more focus on emotional well-being. So by talking with somebody, you might get the boost in emotion, and that reduces depression, reduces stress, loneliness, and then lead to better sleep. And then sleep is very much associated with amyloid accumulation, as you may know. So this might reduce the amyloid accumulation, and then also inflammation, and that's lead to better health. So I-CONECT was targeting to this black ones. That's our hypothesized mechanism. Okay, so briefly, in this series of randomized controlled trials, participants in the experimental group engaged in 30 minutes of conversation with trained interviewers through the video chat. And the conversations are semi-structured in order to standardize introductions, but also to provide cognitive stimulations, such as organizing and then conveying their thoughts in a natural conversational setting, like talking with their friends. And then we also try to expose the participants to different conversational stuff each week, because we wanted to enhance the novelty of experience, or in other words, try to reduce the bounding in this trial. Because as I showed you before, we have two mechanisms: emotional bounding and then social stimulation, brain stimulation. So we wanted to focus on brain stimulation. So we wanted to reduce the bounding side. That's why we wanted to rotate each conversation stuff so that participant and then conversation people are not bounded emotionally. So here is a picture of video chat sessions. All conversations and videos are recorded in a HIPAA protected environment. And we accumulated over 3,000 hours of conversation during the trial, which have been used for speech language and facial expression analysis, which I introduced later. And we have about over 150 themes and picture prompt. So we have a daily conversational theme, which is intended to prompt the conversations. But once conversation starts, conversation should flow naturally. And to minimize confounding effects of brain stimulation from learning how to use PC, the device has to be very simple to operate. So in our system, only one touch, like in the middle part, the interviewer shows up, and then we can start the conversation. So what we found, so here is the result of the first phase 1 study, the small study, which was completed over 10 years ago. We provided daily 30 minutes conversations, 5 days per week for 6 weeks. Despite the short duration of 6 weeks, the results were very promising. The experimental group gained in language-based executive functions compared to the control group with an effect size of coherence D of 0.51. Now, coherence D of 0.5 is relatively large. For example, in the finger trial, which everybody knows, coherence D in the primary outcome was only 0.13 after 2 years of intervention. So this result was already published in 2015. And then as I believe, Mihoko's, Dr. Otake's trial also improved the category fluency, as I remember. Or is that the word fluency? But anyway, the fluency test improved. So it's very similar results. Okay, so in the I-CONECT project, we specifically targeted socially isolated subjects aged 75 and older, either mild cognitive impairment or those with normal cognition. Initially, our inclusion criteria was 80 years old, but due to the low participation of African American subjects for that age group, we lowered the age threshold to 75. And social isolation was defined operationally like this. Rubin's social network scale is low, engage in conversations lasting 30 minutes or longer, no more than twice per week, and then answer often to at least one of the questions in a 3-item UCLA loneliness scale. The experimental group received up to 1 year of frequent video chat with trained conversational staff, along with the weekly 10 minutes phone check-in. Here, chats were provided 4 times per week, which is an induction phase, and then followed by twice per week, which is a maintenance phase for additional 6 months. And the weekly 10 minutes phone check-ins was used to monitor social activities outside the intervention, and then also check the health and mood. Now, control group received only weekly 10 minutes phone checking calls. And as I mentioned, to reduce emotional bonding, we rotated interviewers each week. We made a significant effort to standardize conversational stuff, even though we encouraged natural conversations. 2 examples of standardization approaches are listed here. First, we measured the changes in the negative and then positive effects after the conversation, and examined whether a specific interviewer had a higher than average change in affected items compared with all other interviewers. So the interview was standardization by asking this question to the participants. We also checked word counts periodically to monitor the proportion of words spoken by interviewers relative to participants. So we aimed that participants' word count should be at least 30% of the total word counts. That's one of another standardization. So here are the outcomes of our interest. Primary outcome was changes in global cognition measured by MOCA. Secondary outcomes are executive function measured by category fluency animals, episodic memory, craft story, immediate and delayed recall. And exploratory outcomes are emotional well-being using NIH Toolbox, emotional battery, changes in speech characteristics, linguistic and then acoustic, and then brain connectivity by resting state functional MRI, especially for large networks, and then arterial spin labeling, which measures cerebral blood flow after the intervention. So here is the result. So one of the biggest challenges was recruitment. Socially isolated people do not come to your study or our study. So we have to recruit with massive effort. Originally, we were visiting senior centers, senior community centers, churches, but these people attract socially active people. Socially isolated people, it's very hard to recruit. So after a while, visiting the senior centers and retirement homes and then community center, we didn't recruit much. So we changed to mass distribution of mail invitation. So we distribute about 30,000 mails. And then we finally enrolled 186 subjects. About 20% are African Americans. And then here is after randomization. Our randomization algorithm worked very well, meaning that experimental group and the control group are very similar. So total is 186. So experimental group is 94, control group is 92. And as you can see, age, very similar, percentage women, race, and then years of education, and then MCI participant, MCI proportion of mild cognitive impairment people as opposed to normal cognition is about 50%. So as you can see, these factors are very similar, and we try to be similar by using balancing these factors between the 2 groups. And MOCA score is exactly the same. And as you can see, other test scores is similar between the 2 groups. As you know, randomization, balanced randomization is critically important when we run the clinical trial. because it has to be, baseline has to be very similar between the two groups. And then other test scores is very similar. So briefly, what we found. So here is a MOCA score. After 6 months, this is a MCI group. And then this is a experimental group. Those who had a video chat, as you can see, improved about 2 points. What is control group declined a lot. So this was statistically significant. This is a one coherence D of 0.73, large effect size, large efficacy. And then as for the craft theory, immediate recall, like short-term memory and long-term memory, to 12 months. This is a MCI group again. Short-term memory improved among the intervention group, whereas control group declined. And then category fluency, this is language-based executive function. Again, among normal group, we saw the statistically significant difference up to 6 months. And this result is very similar with our first pilot study. And then another one, psychological well-being. Now, even though we did not target psychological well-being in this study, they did improve psychological well-being. However, interestingly, both groups, this is among normal cognition group, social satisfaction, which include loneliness, it's improved in both groups. So both group is not different from baseline anymore, it's improved. So this is the result. And then MCI group, both group, again, improved. So meaning that for brain function, like MOCA, and then cognitive test scores, very frequent interactions are needed. But for emotional well-being, it may be that just 10 minutes once per week phone call might be sufficient. So those who are receiving brief telephone call per week seems to be doing as better as the experimental group. So this work was done by my postdoc at Harvard, but now she promoted to assistant professor, Choi, and she applied individual treatment response analysis and then examined how much time we can save if we in the delaying, how much time we can delay the dementia onset if you are assigned to the intervention group. So as you remember, experimental group improved this much, and then control group went down. But once the intervention stopped, and then worst scenario, if they are quickly went down because the intervention is over, no more talking, then they sharply decline. Even that scenario, we could save about 6 months. So it takes 6 months to reach the control group's level. So this time delayed effect is nowadays very popular. As you know, like FDA approved 2 anti-amyloid drugs these days. You know, AZI, you probably heard in the news, like that was a big story in the news, I'm sure. AZI developed a very promising drug which reduced amyloid in the brain to treat the Alzheimer's disease patient. And then originally they were criticized because they said CDR sum of box, which is like a cognitive test score, functional ability scores. The difference between control and randomized group is only 0.32, which is very similar, small. But now, so instead of providing mean difference, group difference, the clinical trial are more likely to say how many years or months they are saving if you take this drug. So this is one of the early studies which try to come up with this kind of story, this kind of analysis, applying individual treatment response analysis. So by doing that, we found that at least 6 months can be delayed. So I just mentioned this, usually in a randomized treatment, we do the average differences between intervention and then control group, but there might be heterogeneity. So in a way that if intervention lead to 50% of people improved really a lot, but 50% declined, then the average is 0. So it doesn't, if there's a many heterogeneity who responded to the treatment, this kind of average does not give you much idea who is, more importantly, we have to find out who benefited most from the each intervention. Because we feel not everybody benefit from conversational engagement. So we have to get into much deeper. Therefore, individual treatment response analysis, like we do, is very important. So just in case you are curious, I want to show. So in the individual treatment response, we analyze, given that one person would be placed in control group, and then this person, same person would be controlled to experimental group, how much difference they can gain by being in treatment group. So this kind of idea, you have only randomized control group and experimental group. You cannot say, let's see, how can I say? Okay, how about this? If you are in a randomized group and they didn't change the score at all, intervention group, and he did not change the score, but is that means no effect? We don't know yet, because if this person would have been in control group, no intervention, then he might have declined. So we have to think about, if this person would be given to control group, how much this person is actually declining, therefore how much is a benefit. And then vice versa, if this control person would have placed in intervention group, how much he or she might have gained. So this kind of mutual switching has to be done to evaluate treatment effect. So this is a mathematical formula for the ITR. But anyway, top 30% of people, top 30% of benefited people, responders in the I-CONECT could have reduced, could have delayed the dementia related cognitive decline by 6 months. Okay, and then, all right, so next, another result, which is also done by my postdoc, Dr. Kikishin, and she's also moved to assistant professor now. So 2 of my former I-CONECT researchers are now assistant professor. But anyway, she found that based on weekly telephone survey, experimental group, intervention group, increased time out of house, whereas control group is relatively similar in terms of time out of house. Now, time out of house is a proximate of social interaction. If somebody is going out of house instead of staying in the home and then alone, if they are going out, they indicate they are becoming more active, hopefully socially active, but at least we can tell they are becoming more active. So we use this time out of house as an indicator, proximate indicator of socialization. And the intervention group went up significantly during and after the intervention, whereas control group did not do so. And another factor is that odds ratio, odds of contacting a friend increased among the intervention group, whereas control group declined. So you can see I-CONECT intervention somehow made people more active, more contacting with friends and friends, meaning that they can receive further cognitive stimulations during and after the trial. So that's another one. And then this one, it's my current postdoc, Dr. Liu Chen. He's actually a computer scientist, AI machine learning person. And he checked we have accumulated a video, right? Like 3,000 hours of video, and then analyzed linguistic characteristics. You may or may not know there is one linguistic characteristic called semantic noise. So what is semantic noise? So semantic noise is something like this. If you are talking, let's say baseball, you are talking about baseball, and then participants say, when they were young, his father used to take him to baseball, and we enjoyed it, do this, do that, and saw the firework. So all about baseball. But then topic becomes something like, but his father passed away with cancer in this year. And since then, he hasn't been to baseball game anymore. And then topic become a cancer. Is there any family members, other family members who have developed cancer? Or was it cancer treatment worked or not? And so the conversation often shift the topics. First, they are talking about baseball. Now it's goes to cancer, and it may be something else. But when people are cognitively impaired, they tend to stick to one topic. So it's very hard to shift. So semantic noise is how much group of word occurs in each during the conversation. So very skewed like this, meaning that they are stick only baseball. And even though conversation shifted to cancer, participants still go back to baseball. They cannot switch around the conversation. That shows up like high semantic noise. And this is more evenly. So the normal people, usually semantic noise is more even like this. But cognitive impairment people tend to repeat many things, repeat the story over and over. So semantic noise tend to be higher. So by using that theory, he analyzed at the baseline MCI normal. So MCI people actually higher here, which is our hypothesis. But then after intervention, same group of people, now MCI and then normal group has no difference, meaning that MCI's semantic noise resembled to normal groups. So that's we found here. So the intervention made some shift in linguistic characteristics. So unfortunately, MRI was much smaller than we wanted because we hit the COVID-19 during recruitment, and MRI analysis was halted due to COVID-19. So unfortunately, we have about 55 people who did MRI at the baseline, but follow-up was very limited. Only 9 people actually could do this MRI follow-up in the same way, meaning that only 9 finished MRI assessment at 6 months before COVID started. But even though very small sample size, we did find significant differences. So DAN is DAN, dorsal attention network, which is sort of related to visual and attention span, attention ability. And that was different between experimental group and control group after the intervention. So as we hypothesized and in the cognitive reserve theory, it seems like certain network seems to improve after the intervention. And then we also checked the perfusion, the cerebral blood flow. And then baseline, 43 people can be analyzable for this ASL approach. And then we found that the higher the cognition, their blood flow in thalamus. Thalamus is very in the middle, close to hippocampal region. And this thalamus, the blood flow were higher for those who has high MCI. And then that's the place which improved connectivity, blood flow improved after the intervention. So the conclusion is social engagement seems to help preserve cognitive function by increasing thalamic blood-brain flow in here. So these are all the results. And here, another way of looking at this, if MoCA score, this is y-axis, x-axis is a MoCA score, and then y is thalamic blood flow. So it's a linear relationship. And then all MoCA positive people, these blue are experimental group, and these are control group. We could see the clear separation here. Okay, so these are some of the actual numbers. You know, I show the figure, but if you want to see, this was already published in the top line result paper published in the Gerontologist 2024. And then here we are showing that if we only use the limited number of people who finished MoCA testing before COVID, it was 1.75 difference in the estimate among MCI, propensity of 0.73. But if we impute missing data after COVID and then do the analysis, we still find a significant improvement among the MCI experimental group. So that's what we are showing here. And then these are the another study results, which I mentioned already graphically, like at 12 months, experimental improved in short-term memory. And then interestingly, I just want to mention COVID affects negatively. As you can see, this is a before COVID. We did the dummy variable. All these results before COVID is 0, after COVID is 1, and after COVID itself, you know, it's reduced attention, it reduced immediate report. So somehow after COVID, people's cognitive ability get worse slightly. In the category fluency, animals improved among control, normal cognitive group. Okay, so summary of results. Due to COVID, the sample size was reduced, modality of cognitive test was modified, but despite these changes, we saw potentially meaningful efficacy among MCI group, global cognition improved, encoding learning, short-time memory, long-time memory improved. And then among the normal control group, normal cognition group, language-based executive function improved, which is the same as the phase 1 study. And then in addition to these cognitive test scores, efficacy was shown in resting state fMRI using dorsal attention network and cerebral blood flow improved in thalamic regions. And then daily functional activities, people tend to become more active. They spend the time out of house more often and contacting friends. Linguistic characteristics, MCI people's semantic noise resembled those of normal cognition group after the intervention. So we hypothesized cognitive reserve and then actually reserve, which is like if attention reserve like resting state fMRI and cerebral blood flow improved. Oh, and then Mihoko asked me what we are doing in the community-wise. So after the intervention was over, many participants wanted to continuously do the conversational engagement. So we founded I-CONECT Foundation, like I-CONECT studies is one name, but here we made it more natural spelling, I-CONECT Foundation. It's a 503c1 nonprofit foundation. We founded this in 2020 and then try to provide a free conversation service to more people. Used to be that we only limited to the Michigan and Oregon, and but now it's a nationwide, meaning all states we have a participants. So it's getting bigger. Okay, so I have a few more minutes. So I just want to mention AI-based analysis because Nihoko's, your group is interested in AI. So as I mentioned, we have a lots of audio and then video recording, and that was used intensively by computer science people. So this is called a multimodal cross-transform-based model to predict mild cognitive impairment using speech language visual. So our purpose is how we can identify normal cognition group from MCI group. Now, early detection of cognitive decline is very important. So if we can detect MCI people as early as possible, which is great. So we want to use the facial and speech data whether these variables can detect MCI. So this one is multimodal, meaning that we used facial features and then the language, which is script written characteristic, linguistic characteristic, and then also acoustic characteristics. And then we combined this and then how we can predict. And it was very successful. Its area under curve is about 0.84 by using this multimodal method. Just by using video, we can detect MCI people. And then there are a couple of a few other studies, but I don't explain all this. But again, these are using the facial video only, but there's using other mechanisms like sequence of video, analyzing sequence video, and then how the sequence can detect, difference in sequence can detect the MCI people. There's quite a few other ones. Actually, this is this data is very heavily used by computer scientists right now. Oh, and then scalable diagnostic. This might be interesting because this one, we have a dialogue, but instead of using entire 30 minutes dialogue, how soon computer can identify somebody's MCI or not? So is there any reduced? So it's like a reinforced learning environment. And then we try to come up with a shorter conversation which detect well the MCI subject. That was published in a scientific report. So that's all about my talk today. And thank you for your attention. Thank you.
Thank you very much. And so, any questions?
Thank you for a great talk. I'm interested in semantic noise. Semantic noise. Yeah, I think it's such a quantification of speech is important to establish the beneficial conversational style, and it leads to address the question of who benefits from intervention. So my question is, how much the speech content is restricted in training the conversational stuff? So you mentioned the standardization of interviewers, 2 points, and the changes in negative and positive effects and words count, right? So any other factor is controlled to give conversation to participants in intervention program. So the reason why I ask this question is, you in the slide related to semantic noise, you mentioned people with MCI at baseline stick to a specific topic, but after the intervention, people with MCI shift to normal people. Yeah. So
resemble they are.
yes. So I'd like to understand the mechanism behind this result. Is it naturally shift to normal people, or any specific conversational style is included in the intervention program? So speech style is instructed. Specific speech style is instructed to conversation staff or not? This is my question.
Yeah. So we did not. So we made it normal. The MCI became normal, similar to normal groups, normal cognition groups, semantic noise. So frankly, why their semantic noise became lower? Its mechanism is still not certain. Are they shifting more conversation, more like learning how to interact with people? So they get more fluently, more smoothly interacting with the interviewer. That's why semantic noise reduced, because they are flowing conversation more naturally. Or their memory improved, so they know they cannot repeat the things many times. As you probably know, when they start to develop MCI, they might repeat things many times, coming up again. The story, and then go back to some other story. But then I say, oh, by the way, I did this exactly same things, repeat again, right? So if their memory improves or cognition improves, and then they don't do that anymore, or they're just acquiring the skill to converse more naturally with the interviewer. We don't know yet. So that's a good field. We have to do more. We have to go into the script, actually, not just machine learning and then categorize, and then semantic noise, but actually to see the interview, how they're interacting, and then find out why semantic noise goes down.
And I have a
very good question.
I have a tiny question, and I have also a very tiny question about in the in university, rotate conversational staff every time. Rotate. So so the study participants talk with different conversational staff every time.
What did you say? I couldn't. The microphone's quality is not good.
Conversational staff switch every time, right? So yeah. So my question is very simple. So how many conversational staff were involved in your study? So the very intention of this intervention is very very strong, because 30 minutes every day, except weekends for 6 weeks or 6 months. So I guess many people are involved in your study. So how many people are?
The good question, good question. And I have to apologize. It's unclear, right? They rotate every week. We rotated every week, but since limited number of conversation staff, so we end up using a couple of interviewer multiple times. We try to spread out. The peak time, 16 conversational staff were working for us to do this about 186 divided up to 60 people, right? 70, about 80 people. Yeah. So we try to assign, but it is true that 16 was not enough to,
Yeah.
do each time.
Yeah.
But the duration of, but still, if you do one first week and then second time to see this person is the third week, third month. So that's quite a big distance. So what we wanted to avoid was every day, talking with the same person, then become emotional bonding. And then also they know each other too much. So the conversation is not stimulating anymore. So stimulation, we thought is very important. So every time try to new people, meeting new people.
Okay. Thank you. Thank you so much.
Thank you so much for a great talk. The question I had was surrounding how you scripted the conversations to go. So part of it is that, did you start with the same sentence every time, like asking, how are you? Or how did you train the people who are having the conversations with these older adults?
So that's very good question. I didn't explain the flow of each sessions so well. So that's great. So there is a daily conversation topic, like let's talk about pet today. And then we show 3 pictures. One is exotic dog and cat, which is very common. And then like another one is service dog. And then which topic do you like to talk today? And then subject can choose, okay, let's go topic with exotic pets today. And then we show the picture, relatively stimulus picture. And then we ask, what do you see in the picture? And then participants explain, oh, I see the big snake, being captured in the cage. And then, so they explain the pictures. And then in each session, we focus in, one is reminiscence. Reminiscence meaning when you were a kid, did you have a pet? What was the pet's name? Did you like him or her? So the reminiscence is we talk about past things. And then we also try to improve vocabulary, like how many different types of names of snakes can you pick up, like cobra, python, and they have to think about what kind of snake, types of snake. So that's one is vocabulary. And then last one is opinion piece. Now in the rainforest, many of the exotic pets like this are dying or extinct. What do you think the best way to preserve the number of exotic animals? And they have to come up with a sort of opinion. So we always address this reminiscence, vocabulary, opinion. That's the core of the component. So regardless of topic, that's we trained our study staff to go over. And then we usually train at least 10 elderly people, real elderly, before going to the field and then do that talk. So that's one thing. And then they always start like, hi, how are you doing? Hey, this is a trial, thank you for joining. How was your day? How was last week? And then sometimes weather a little bit, and then show the picture and then prompt.
We have a question from the online as well. Thanks for inspiring presentation and congratulations on your results. I'm curious about the trained conversation instructors. So how crucial were their training? So it's similar to the previous question, and probable younger age to the intervention's success. Do you think a similar intervention would work with age-matched, non-trained conversation partners like our study? So non-trained and older people. And then so what will happen, do you think?
Yeah, I think the efficacy might be even greater if we use a different age group, because there is already evidence showing the intergenerational relationship is more stimulating. So using very young people, for example, young interviewer, and then older people, that's a good combination, I think. We did not limit our age. So there are some very young right after college for I-CONECT. And then some are very old, like their buddies type. So age range were very big. So out of 16, half, about one third is young, like right after college or master's degree, or still in the nursing school. So the school, people like 20s. And then the other one is 40s. And then the other one, additional one third would be 60 to 70. And I think we did not collect any data about which partner do you like? Do you like talking with younger people, older people, male, female? We did not ask that question, but I got the impression that they like to talk with younger people. Yeah. So, and then I believe so because this intergenerational thing is getting very popular, and then they tend to have more cognitive stimulation. Maybe generational gap is a good thing because they try to learn each other, more stimulating, but the same age might work too. But that's we can control next time. Thank you for the good question.
Thank you very much. So in general, yeah, younger people are more popular for older people. Yeah, yeah. What we found through the experiments
Yeah.
that so instructors are younger and then they get more excited. So it depends on person to person. So maybe it depends on personality.
Yeah.
Yeah. Thank you. And okay. Yeah. So thank you very much for your exciting talk. Yeah, for now, we may report on also on cognitive intervention via conversation and robot moderating group conversation for cognitive intervention to healthy older adults. And so this is the statistics of the dementia prevalence by age group. And so it is said that era of the life up to 100 years old and 80% people over 95 years old have dementia, which study shows. And so my grandmother who passed away at the age of 96 also had dementia in her later life. And so this is one of my motivation. And so I got curious about dementia and cognitive decline. And so this is one of the so important historical study of non-study. And at the time of their enrollment, sisters agreed to periodic cognitive and physical assessments throughout the rest of their lives, as well as brain donation at death. And so 88% of sisters passed away without dementia, although their brain had pathologically Alzheimer's disease. So this is one of the famous findings that pathological change and cognitive functioning are not equal, which also Professor Ash mentioned in the previous talk. And in this study, they found that language ability was high for such people when they were young, and in other studies afterwards, so their language abilities at older age also help to maintain their cognitive functioning, even though they have pathological change. So there are two ways to maintain cognitive functions. So not to decrease the numbers of neural cells by diet, exercises, and sleep, and so vascular, in order to prevent vascular dementia. And so this is a physiological approach. And another is not to decrease the numbers of neural networks and synaptic connections. So it's intellectual activities, social activities, and use of languages are the way to keep the network. And so this is a cognitive approach. And so the latter one is the basis for conversational intervention. And so this is the hypothesis that conversations may potentially serve as cognitive intervention if the condition met, since one's speech is an output of brain, as well as other speech is an input of one's brain. So we can, well, design the input and output, and so network connection in the brain. And speech in conversation may also predict cognitive decline, since one's speech is an output of brain. And so which already mentioned in Hiroko's work based on the data collected in I-CONECT project. And so this is also one of the famous work on social network and dementia. And lack of social interaction may higher the risk of developing dementia. And so people with poor social network had 8 times higher for people with extensive social network. And so these kind of findings were really reported in from the different groups and in observational study, but there are very few intervention study. And so when we started this study, we couldn't find other than Hiroko's work actually. And so I think up to now, not so much. And maybe recently there are a lot of chatbots, and then many people may try to validate the effects on cognitive functioning, but maybe it's ongoing. And so the impact of this study is that while a systematic review found that social activity intervention may help maintain cognitive function among healthy older adults, there are no global recommendations for social activity interventions related to cognitive health, because evidence of the impact of such intervention is limited, which means that number is not enough right now. And then one major reason was the lack of technology for generating quantitatively and qualitatively consistent social activities necessary for cognitive intervention. So in the last talk, there are questions about instructors. So the conditions for the conversation might impact the effects of the conversation. But designing or controlling conversation is not easy in general. And so sometimes as a result, some may talk a lot or excited, or some may not feel so excited or feel boring, for example. It depends. So it really depends on the people who are engaged in the conversation conditions. So building social network via conversation is our challenge. And interactive conversation is a base of social network as well as an intellectual activity. However, some speak and others not, and some listen and others not. So it is difficult for intervention. And so we have developing a conversation assistive technology to realize a kind of somewhat controlled, but also exciting conversation. And so we named the method co-imagination method, invented for balancing speech and listening. And so we set a theme, and then participants prepare photos according to the theme. For example, favorite things or favorite foods or favorite things in your neighborhood or seasonal things and anything. And so every time the participants are assigned for taking photos for the next time. And then on the conversation session, times, pairs, and turns are determined for each participants. For example, a first turn, 1 minute for one photo for talk, and then so it's a talk and listen session. And second turn, Q&A session, and 1 photo for 2 minutes for questions. And so we named collective and cooperative imagination. So imagine imagine with each other through conversation. And so in this way, if each participants have 1 photo, and so in groups in 3 minutes, 3 people, And then, so 1 + 2 minutes for talk for each participant. And so 3 members, and then in total 9 minutes for talk, listen, and questions and answers. And in order to realize cognitive intervention via social activities, we developed novel technology to promote intensive conversations among adult adults and demonstrate the effects on older adults' cognitive and brain functions. And so we also developed to predict cognitive functions from different modalities of behavioral or physiological data, aiming to monitor cognitive functions in everyday life. And so at first I described conversation for cognitive intervention and its assistive technology. So this is the overview of the developed system. Cognitive behaviors assistive system with conversational assistive AI. And so there are 3 modalities we have developed. One is for conversation face-to-face, and then another one is dialogue system. And another one is for remote communication support system. And so we started our team in 2017, and then did face-to-face experiments in 2018 and 19. And then pandemic came. And then so COVID came, and then we did the trial with dialogue system in 2021. And then trial with remote communication system in 2002, 3, and 4. And then so in this year, we may not do run RCT, but a kind of follow-up study of remote communication system and to do the face-to-face intervention. And so here is the face-to-face intervention system, a robot moderating group conversation. And here I show how the robot works. And so this is this room, actually.
これから競争法を始めます。
So the robot
テーマは最近食べて美味しかったものです。
そこで開発されたのが、競争法の司会を行うロボット、モノちゃん。
小島サイモンさん、写真についてお話しください。
Shown on the screen. This is a picture taken by
小島サイモンさんの写真についてご質問お願いします。
キャンプの前って結構時間があったんですか、その。
そうなんですよ。
搭載された AI がそれぞれの会話時間を計測して、会話の流れを自動的に整理します。なんと量、聞く量のバランスを整えることで、誰もが平等に競争法を実践できる環境を作ります。
If people speak too much, and then the robot may say,
じゃあどっちも
長く話しすぎる人がいた場合は、モノちゃんが割り込んで話を終わらせます。
佐藤清さん、ありがとうございました。熊谷和美さん、ご質問をお願いします。
あまり会話をしない人には話をするように促します。いくらぐらいだったんですか？ロボットだからこそ人間関係が悪化することを恐れる心配なく、スムーズな司会進行が可能になる。どのくらいかけていいかわからなくて、たくさん投げちゃうとなんか困るな。
every time the same moderator moderates. So we could, well, make the conditions in the same conditions to this experiment. And then, so this is a paper published about this randomized control trial. And we named this program, named PICMORE, a photo-integrated conversation moderated by robot program. And so this is the overview of the flow of the program. It's present preparation stage. Participants take photos based on themes using smartphone app. And then so using app, we can upload the photos to the database. And then during conversation session, so the photos which participants took beforehand are displayed one after the other. And then so we give a talk and ask questions with photos, and the robot moderates the flow of the conversation. And at recall phase, immediate and delayed recalls of the photos and talks are done. Like photos are randomly shown on the screen, and then on the tablet screen, and then who took this photo, and then answer to the speaker, answer the speaker of the photo. And then so it has been done just after the conversation. And so this program was done every week. So 1 week after the previous session, and then the participants came after 1 week, and then do this recall at first about the last week's conversation. And then so this is a time management of the program of 1 day. And so in this way, in this talk, in this study, 2 photos for 1 participant. And so 4 people are in 1 group. So 4 photos and 2 photos and 4 people. And so 1 for each participant, 2 minutes for talk, 6 minutes for listen, and 4 minutes for answering questions, and 12 minutes for asking questions to other people. And so in total, almost 30 minutes, including the moderation of the robot. And so we could control quantity and quality of interaction and intervention. And so this is the algorithm to control the amount of speech. And so the system measure the amount of speech of the participants and calculate the average of the speech of each participant, and the particular person's length of speech is lower or smaller or larger, and then so the robot start intervention. And speech, so who proceeds to talking only, or who hardly takes part in the conversation is detected automatically. And so this is the consort for diagram of randomized control trial. So this is almost the same size of so Hiroko's first trial. So 72 participants for screening, and so included 7. And so baseline measurements were 65 people, and so there were no withdrawal. And so intervention group for 32 people and control group for 33 people. And then intervention group took pick more group conversation with kind of lectures on pick more. And another group did just chatting without any conditions and just chat for 30 minutes with kind of healthcare literacy lecture. And did post measurement. And we found that verbal fluency improved for intervention group from 11.8 to 13.6 on the average, while control group 11.4 to 11.2, almost the same. So, and this verbal fluency was also observed. Change was also observed in Hiroko's work in 2015. And so, and then, so this is a number of words starting from ka in 1 minute. So kaki, kaku, kake, and so the participants try to recall the words starting from ka as much as possible in 1 minute. And then the number has increased. And so by controlling the amount of speech, we could successfully so control the amount of speech, and linguistic characteristics improved by intervention. So no significant difference between control and intervention in the number of words. The number of words are almost the same, but participants in the intervention group spoke more evenly than in the control group. So the variation was larger for control group in the graph in the middle. And so left part is so control group. And so this is an intervention group. So really, well, diversity was smaller. And then another one, the number of words. So the participants in the intervention group spoke more evenly, and the program intervention led the speech to contain more diverse information, improved vocabulary richness. The number of kinds of words to the number of words were larger for intervention group. So fewer repeated use of words in their sentences. And we also did MRI studies on the effects of PICMOR for this study, and did resting state functional MRI, functional connectivity, and voxel-based morphometry, and track-based spatial statistics analysis of diffusion tensor net imaging. And for characteristics of resting state, we found that so the areas semantic and executive control related regions have larger connectivity. So this may describe the improvement of verbal fluency, and also we found the superior frontal gyrus was greater in the intervention group than in the control group, and so it's also relates to the change. And no region showed greater volume change in control group than in the intervention group. And also conversational-based cognitive intervention have the potential to maintain to improve white matter fiber health, because left frontal white matter structures are candidates, and so contribute to the intervention-induced enhancement of verbal fluency. So the white matter, so regional network has improved was larger for higher intensity in intervention group. But we need to note that it was only for post intervention because of the preparation of the for measurement, and so we need to explore more for different trials to measure pre and post of MRI data. And then we developed dialogue robot system for cognitive intervention. When we developed, it was the era before ChatGPT. So we used more classical FAQ-based system. But the interaction is similar. And then so this is a program. So the robot is there, not yet prepared so much, but this is the same setting.
質問力を鍛えるために考えられたのがミニボノちゃん。
15年3月5日です。それでは、これから競争法を始めます。
グループではなく、1対1の対話で競争法を行えるモデルです。
僕は、セリを育てています。
タブレットの画像と組み合わせ、ミニボノちゃんが話題を提供。
それでは質問をお願いします。
By the real order dog, and so we selected some of the interesting stories
セリは
from the real order
ど
dog.
れぐらいで大きくなりますか？
And then
セ
we
リは
asked
通
questions
常、
to the robot.
成長に約1ヶ月から2ヶ月ほどかかります。
セリ以外に育てている植物はありますか？
会話の中でも特に難しい質問力を効果的にトレーニングすることができます。
育てています。
問題一つで簡単に操作できるので、
どこに住んでる
So
んで
this
す
is
か？
carefully
冬は
and
寒そ
asking
うですね。
question is the most
僕
difficult
は
part.
埼玉県のベッドタウンに住んでいます。
Participants can, intensively train that part of listening carefully and asking questions. So people with dementia can talk what they want to talk, but it becomes a bit difficult to understand so fully or others talk, because sometimes the meaning of words they do not remember, for example, and they cannot comprehend so much. And so if the people are maintaining cognitive functions, and then we thought it is recommended to do this task. So listen carefully and asking questions. And so this is a background dialogue-based system with photo and storytelling for older adults. And so usually chatbots has, dialogue system and Q&A, and so conversational agent, And then there is a tablets, and then do the kind of communication between that background crowd system and the app. But for doing co-imagination session, we need another mechanism to manage the schedules of putting the stories at certain time, as well as the contents to obtain when the topic are done. And then we switch these contents, and then we schedule for each participant when to talk and ask questions. And then these are managed using this. And then the logs are as well stored in another system. And so this the system was published in 2021, and the result of the trial has been published in 2024. And so this is a consort flow diagram of RCT. And so this time, the intervention intensity is not so strong. 2 to 3 weeks intervention, and then 6 times within this period. And then, in each time, 2 stories are given by the robot and asked questions to the robot. And then verbal fluency improvement was not significant, actually. P-value was 0.09. And so, but number of words, starting from ka in a minute, the average or number of words were larger for intervention group, but but not significant in this time. But we hope that if we increase the number of stories and number of periods of intervention may improve verbal fluency. So this is a kind of preparatory results, but it's a promising results. And we did remote communication system developed and did intervention study.
スマートフォンやタブレットを使って自宅から参加できる遠隔競争法です。
To do
参加の仕
co-imagination
方は簡単
session
です。
using
あら
smartphone
かじめ決められたテーマに沿った写真を用意し、
app.
当日はスマートフォンやタブレットから参加。
a common system for face-to-face and remote. And so when the scheduled time, the music plays.
会話開始時刻になるとお知らせの音楽が流れます。 その合図をきっかけに会話に参加します。
The button, and then they can enter into the room for chatting. For
司会者の進行に従って用意した写真について制限時間内で話をします。
so the rules are same as the face-to-face.
この時、同じ写真が全員の画面に表示されます。
So now he's talking about this photo, and then
その後は制限時間内で他の参加者からの質問に答えます。制限時間が来たら次の人に交代です。 遠隔競争法の良いところは、インターネットがつながれば、いつどこからでも会話に参加できること。地域や世代を超えて多様な人と交流を深められるので、話題が広がり、認知機能の向上につながります。
Experiments so we didn't meet any participants during this intervention. And after the pandemic, so in Japan, 2023 May, so it has become possible to do experiments, and so face-to-face experiments, as well as to do meet with older adults, so officially. And so as a result, after that, we could do face-to-face, but before that, we did. And also, we partially continue this experiment because during pandemic, many participants in other area of Japan participated in these experiments in a kind of continuous manner rather than RCT. And so we are following up experiments of this type using this system. So this is a protocol paper. And then so we are in the final stage of results paper. Although the first year, 2022, the intervention effect was not significant, so a bit difficult to write a paper. But for 2003 and 2004, we have some difference with between intervention and control group. So we hope we can publish much simpler. And so we could find some kind of good, positive, both negative results so that we can see what is the necessary condition to have intervention effect. So conversation intervention is maybe relatively, not strong compared to maybe strong exercise or with very, medication. But so it should be, more, the intervention will be more and more maybe diverse or the effects varies for each people. So we need to be more and more individualized for better or stronger effects on each participant, we think. But it's up to our future work. And then prediction of cognitive functions from physiological and behavioral data is another study, study. And so one is via conversation. So we collected a large number of conversational data. And so Hiroko also reported about the characteristics of conversational data like speech and visual. And so we could identify the MCI and so from healthy control. And so we found the vocabulary. We found scaling laws in natural conversations among elderly people. And so spoken language and cognitive functions have relationship. And so we found the scaling laws, namely Heaps law, in respective of cognitive function. And that the variation in Heaps exponents were associated with cognitive function. And this affects vocabulary in richness. The results suggest that we can predict the cognitive function of the speaker through analyzing transcribed conversational data. And so so number of words for this line, and then axis, and then so number of different words for y-axis. And so if people have large vocabulary, they do not saturate. So and then so it increase. So while the number of words increase and the number of different words also increase for larger vocabulary people, and less vocabulary people, so it saturates and do not increase number of different words. So this is one measure. And another is brain status associated with vocabulary richness. So we obtained data for each participant and whether there is associated brain areas. And then we found that as individuals with higher beta showed a greater volume of the left anterior middle temporal gyrus and the weaker resting state functional connectivity between this region and the precursors. So it's also, it may, have some, maybe the network of these areas might have changed through, and for people who accumulate vocabulary, who have much vocabulary. And so people with much vocabulary means they accumulate new words they remember through their everyday life. And then so they might have some more attention to words or to try to remember. And then also they try to retrieve. And so such activities reflects the vocabulary richness and also the network which in such activity. So there's another analysis, time orientation of order routes in group conversations. And so utterances in group conversations were classified in terms of time and experience or knowledge. Because if people talk about only past and they do not talk about recent, means they might not remember recent topics. And so, of course, they know, but they do not deal with, or they cannot remember, and then so they cannot talk. But it depends. But logical memories were associated with frequency of utterances that mixed past experience and knowledge, and those about recent knowledge. So we found that people with higher memory functioning tend to talk more about recently acquired knowledge. So this is really intuitively true, but from the data we have found that it was true. And from the questionnaire, we also found very interesting phenomena, that association between social comparison orientation and cognitive and brain health in older adults. And so there is a questionnaire named Social Comparison Orientation Scale. Refers to the tendency to compare oneself with others and has two distinct dimensions, one about opinion and the other about ability. So people who are interested in comparing others of their opinion tend to have stronger resting state functional connectivity, greater volume in the hippocampus, and higher fractional anisotropy in white matter fibers. And so, who tend to compare ability of others, themselves and others, such relationship were not found. But people who are interested in comparing opinions tend to have better cognitive functions. And this is also really a kind of intuitively, well, reasonable. Because in order to compare opinion, we need to buffer the others. Well, we need to listen carefully and buffer the ideas, and then buffer their own ideas and compare these ideas. So working memory functions should be so required, as well as some kind of, well, really attention requires, and so executive functions also required. And so, well, we found a good, well, characteristics or kind of, well, scaffolded network for such people. And so we also use doing EEG data study, classifying mild cognitive impairment from behavioral response. And so the point is which cognitive task can be done for both MCI and healthy controls, as well as whether we can detect the difference to the response to each cognitive task. And so we explored several candidate cognitive tasks and found such emotional arousal and balance evaluation tasks and other, for example, reminiscence, reminiscing images, viewing task, and audible task, and some tasks are, well, effective for identifying cognitive decline, as well as explored machine learning methodology, as well as some processing unsupervised and supervised machine learning. And so approach allow us to separate and classify network and neuroscience features for positive subsequent diagnosis of early onset dementia. So by a kind of, well, geometric, well, separate, and so a network topological, transformation of the data may really, this will separate and classify, and so these two groups we found. So this is also the approach, and so we are also applying for another dimensions of physiological data like eye tracking data, and so on. And to summarize, we have succeeded in developing novel technologies which enable cognitive intervention through social activities in order routes with evidence and face-to-face, dialogue robot, and remote communication. And novel technologies to predict cognitive functions from different modalities of behavioral and or physiological data. And example, conversation transcribed conversation, a questionnaire and EEG data. And also we are analyzing acoustic data of conversation as well. And so after I-CONECT study, Hiroko founded I-CONECT Foundation. And actually we are we have founded Bono Research Institute. In the very beginning of our study, before RCT, more exploratory stage, we started this kind of participatory research. And participants become practitioners and follow-up participants. And then real senior researchers, and their average age is 75 and maximum 19.4. Yeah. And then with them, we developed a robot in the wild at walking and talking workshop. Walking and talking workshop, for imagination, is a one-day program. Then taking photos, and they return, they talk. Yeah, walking and then find something interesting in the town, and then this is picture they get interested in. And then for each participant, select one of the best photos in the day, and then give a talk one after the other, and ask questions with each other. And so they can try this. They can experience this session in one day. And so future work, we would like to discover underlying mechanism of impact of conversations on cognitive functions. And so we did a conversation intervention trial, and then we would like to compare findings and data analysis in I-CONECT as well, and imagination-based conversation interventions. And develop technologies based on mechanisms. And another direction is social implementation of conversation-based intervention services. And so hold workshops and RCTs in all over the world to study cultural acceptance and intervention effects, and to adapt technologies in diverse culture and fields. Yeah, so I did some demonstration in Europe with a robot, and so many participants said that cultural acceptance may be different in different places. So I think we need to bring more to other places, and whether how they feel, and whether they enjoy or not, and whether it's really effective or not. Thank you very much for your kind attention. Any questions? Thank you.
Thank you for the talk. I had a question on the robot that interrupted the person if they talk too much. Did that change the perception of how the person kind of reacted towards the robot after it was told to be quiet, after the person was told to be quiet? So did the person dislike the robot more because of it, or did they stop talking as much? How do they react to that?
Yeah, that's a very good question. So we compare the system with only a speaker and the robot. And then overall impression was not different. But for the people who speak too much, they prefer speaker rather than robot. They don't want robot to look at that person and stop. So just the speaker is from the ceiling, and just how about talking, stopping, and yeah.
I had one more question about the cultural acceptance part. Is actually interesting because the people that I talk to in the United States, they're like, it's weird to talk to a robot. So at least in Japan, are people more have more acceptance of robots
Yeah.
and talking to robots?
Yeah, at least in Japan. So this system were accepted by the older adults as well as any other generation groups. So basically, and also the looking is more like a doll rather than a kind of humanoid. So it's more so we by design try to be more acceptable. So I hope people will enjoying doll, and so because dolls are almost prevail in all the cultures. So if it looks like more like a doll, and then it might be acceptable, is our hypothesis.
Thank you for the great talk. It's very interesting. I have one question. The robot sense who is talking less, who is talking more, and then interrupt. Are they doing estimating the? Do you use word count or duration, or what do you use as a metric?
Yeah, we use duration, and also duration of speech always a kind of space between the speech and speech, and once they stop talking, and so others also stop talking, and then so the robot intervene. And so this is one case. But if the person speaks too long without any space, and then the longer longer than a certain length of speech may interrupt even without any pause of the talk. Yeah, so there are two conditions to intervene in.
And they can intervene while somebody's talking.
Yeah, if the speech is too long without any pause.
Yeah, so
Yeah.
So that's nice that robot can do that. Humans are very hard
hesitate to do
to
that.
interrupt.
Yeah.
That's nice. Okay, thank you.
From the online, is there any questions? Oh, following up of Prof. Daj's comment, do you envision robots playing the role of younger or stimulating members in conversational interventions? I see. That's another. So the younger instructor are more popular than other generations. And then so moderator robot may play a role of such person is another way of designing the moderator. And so this is a comment, and I think it might be. So the kind of appearance of moderator is another research topic for acceptance and also effective intervention as well. And of course, we are planning to combine the two different streams of dialogue robot and moderator robot. And so moderator robot also will kind of more behave based on the contents of their talks, for example, like kindly voicing something or so tell them to ask questions rather than comments. So sometimes Q&A session tend to talk about their own experiences rather than asking questions to the speaker. And so if it becomes such situation, the original speaker didn't get any questions from the other people. So we are planning to make the functioning of detecting whether the speakers' utterances are questions or comments, and if too many comments without any questions, and ask them to ask questions. So that's another role of moderator for this kind of group conversation.
It seems like your project was broadcasted by NHK or some TV, correct?
Yeah, actually, so TV program also broadcasted, but for NHK, we cannot use for upload to YouTube. So we developed look like NHK.
Oh, I see. Yeah.
Not NHK. Actually, the 3 movies. So she's the director of the NHK E-tele channel.
I see.
So it tastes like.
Yeah. I thought that the broadcast. My question was, if it will be NHK or any broadcast, you get more request to do this
robot conversation in the community, but
Yeah. So
someday,
they got interested in it, so they broadcast it previously. And so we would like to, make this into the market in somehow. But who pay and how much? And that's another. So it's for free. And they say, yeah, it's fine. But it's not for free. And then, so who and how much and how, whether I can have good effects. Because so the effects of each participant is really diverse, as you know. So even if they pay, but we cannot guarantee that you can definitely have good effects. So we need more technology to detect the change or effects of each participant, and whether they are going to the right direction or wrong direction, or they match their personality and the program. And then so their functioning or emotional state has becoming better. And then so we can recommend that person to pay. So in order to make it business, we need another. Yeah, and so of course we are trying to develop such, a subtle change detection technology as well. Another question. Thank you. That would be cool to use robot as a cognitive simulator due to technological novelty. Yeah, so the audience said it's cool. Yeah. So because as you mentioned, so training instructor is not so easy sometimes. And so and also from the scientific point of view, we can make the condition exactly the same using the robot in terms of instructor. And so and also Q&A robot, we can also control the stories which provide each participant. And so so vice versa is also we are planning that user give a talk and ask questions from the robot and answer to the robot. And so that's another role for during core imagination session. And so by combining two parts and implementing, and then so we might be able to test the whole function or effects of such conversation with exactly almost the same condition. And also in terms of business, maybe it's, we can definitely, somehow guarantee the effects of, because the contents are same or might be optimized for each participant. Yeah, so Hiroko mentioned that participants can select subtopics from one theme and 3 subtopics, and the participants select one from 3. And such kind of optimization is very effective, I think, for each participant. And so I hope we can prepare such system for dialogue robot so that participants can get more and more interested in each stories of the robot. Thank you very much. So it's about time. So now let's start the dialogue. So based on the 2 lectures and so many questions. Thank you very much for questions. And so if you have overall questions or topics to discuss, so please raise your hand. And so there's a mic here. And so it's maybe the first topic which I raised is that so conversation is really a kind of individually different. So even the same activity may have different effects on each participant. And so people who get used to talk may have not so much cognitively demanding task to give a talk, but people who speak less and maybe talking itself is a kind of cognitive task for the person. And maybe listening is vice versa. So people who don't listen usually, they feel more cognitively demanding to listen carefully. And people who used to listen to others, they don't feel not so much demanding to listen. So how can we manage this?
Oh, I see.
effect?
So for the maximize the benefit of conversation, we recruited socially isolated people
Yeah.
in the I-CONECT, for
Yeah.
example. So we intentionally selected those who do not talk.
Talk and
So the
not
talking
listen,
become more
maybe.
innovative.
Mm.
Anything new is good. That's the Dennis Park who provided a scaffolding theory.
Mhm.
She found any activity is good to bring as long as it's new.
Mm.
If somebody is playing piano already, teaching piano is not necessarily
Mhm.
boost the brain
Mm.
functions. But if you never played piano, learning piano, something new, it's always good no matter what they do. So yeah, so we have to recruit high risk people in your case too.
Yeah.
That way effect size is bigger.
Maybe, yeah.
Yeah.
And then so people who are isolated or have less social network, sometimes they prefer to be isolated, and some are not prefer to be isolated, but other environment they are isolated. So in your case, so the recruited people prefer to be not isolated in general, or some of them in reality they are not they don't want to be so involved.
Yeah,
not.
so still this is the randomized controlled trial, so they have to participate voluntarily. That means even though we target socially isolated people, ultimately they have to come to us. So that means we are already selecting somebody who
Can
wants
come at
to,
least
at
once.
least who wants to talk. So that's sort of a selection bias. You know, we cannot talk with people socially isolated and who do not want to talk to anybody, then we never be able to recruit. But these people might gain most, we don't know yet. Yes.
Yeah, so this is kind
Yeah,
of
it's
fundamental.
Yeah, fundamental things, yeah. Selection bias.
Yeah, and so my hypothesis is that even they are getting involved in social network, but the kind of communication style are diverse. And some of the communication style, like for example, speaking too much but not listen to, or vice versa, may have some risk, I suppose. And that's one of the reasons we recruit socially active, but still they have some risk of cognitive decline. So some of the, for example, so hearing loss is a risk factor for dementia. And so of course there are many cases and different cases, but some of the people who have less hearing functioning tend not to listen so much. So which is the earlier, so they cannot hear so much and they do not listen, they do not listen and then they cannot hear. But because listening is not just a kind of acoustic problem, but more comprehension or interpretation. So people don't so much care about interpretation, tend to be less, so have some difficulty in listening sometimes.
Yeah, yours is group therapy. So you, as you mentioned, always some people might want to talk more, and then some people talk less. Yeah, and the robot can shift between these two people. Yeah, my case is one-to-one, always two people, and the interviewers control the shift, which in a way a little easier
to control
the amount of each conversation. Yeah.
So the kind of instructor are trained to do balance or as they like, or is there any?
So the other one of the standardization approach was the conversations interviewer talk less than participants, and the participants' word count has to be 30% or more about out of entire word count. So about each week we sort of calculated, how many total word count the participant is, how much percentage of total word count, but what was done by participants. And if it's lower than 30%, we ask the interviewer, hey, this person is not talking. You have to be careful, or you have to,
more weight.
induce more conversations. But ultimately, everybody seems to start to talk more as as we talk more. So that's interesting. Because at the beginning, people may be shy, or people may not used to talking, so they talk less. But as time goes by, many start to talk more, so which is a good thing.
So in order to, so Reina.
For the part you just mentioned about them talking more, when you switched out the trained person, did that cause the person to talk, the older person to talk less? Because I feel like humans are social creatures, and we bond with the person, and the more we bond with them, the more we're willing to open up. So I was wondering if you noticed a difference in how much the person talked if you got a new trained person.
Yeah, I think a skilled interviewer certainly improves the word count from participants. So we always say, don't ask questions, yes, no questions. Do you like banana? Yes, no. That's not a good question. More like, why do you like banana? So that participant can talk. So it's I think a skill, partly it's skill. It's of course, some participants are shy, but regardless of characteristic of participants, interviewer has to be well trained so that they can bring up more conversation from each participant.
Any questions? Okay. And then so I have another topic on the kind of doing new research topic. And then so you are the first researcher who started conversational remote conversational intervention for healthy and older adults. And then so in the beginning it was not some researchers are skeptical, and you mentioned, and then so how did you convince yourself?
That was a challenging. So first pilot study, small study was funded 2010. We started in 2010, but it took about almost 3 years to get the NIH fund that study because our proposal always goes to neurology group. And then neurologist was very skeptical whether conversation, such a naive intervention actually boosts cognition. So it took 3 years to convince, just rewriting.
The first proposal in 2007, you mean?
2010 it started, right? 2010.
She started to write proposal in 2007.
Yeah, it's just about the time when Skype was emerging.
Emerging.
So
did you start
beginning.
Use Skype for the first study?
We developed our own system so that we can just do the touch tone. Skype was still difficult to older people because they have to use a mouse. So we couldn't use Skype. Then also in a security issues, Skype is our conversation goes up to cloud, and then anybody can access if hacker wants to access. So that was not allowed in our IRB. So we developed
peer-to-peer communication.
Even peer-to-peer communication. Skype was once it goes up to cloud. So we have to establish the system where everything goes to our university's cloud system. And then HIPAA compliant, meaning that all the PHI has to be in a firewall system and nobody can else hack it. So we developed our own system, which is the interface where we can push the green button and then show up interviewer. And that took quite a long time because technology was still raw that time. So it's
When did you started developing the customized original system after you got grant in 2010?
Correct. Yeah, 2010 it started, but I think 2010 intervention started, right? So 2009
Before
we
that.
probably funded, and
Yeah.
then it took about 1 year to do the IRB and then system development.
Yeah.
And then we moved to intervention.
I see. That's interesting because I invented co-imagination method in 2006 in October.
Oh, so it's just about
Yeah,
the
almost
same.
the same. Yeah, and then I started to do the co-imagination session to real older adults in the town, living at their home in 2007 January, and without any funding. So it was really exploratory. So just going to the local government and so asking for volunteers to participate and yeah, very.
When you say without any funding, so how did you fund the no government funding, you mean, but there's a private funding?
Yeah, at that time, so just to really go out, and then so their participation was for free, and but so our system was really a kind of just a laptop, and then show their camera images one after the other using very small system, and only within the laptop was the first version, so it was very quick.
Yeah, so we did the same around the same time. We got an idea 2006, 2007. Yeah, Skype came, and actually, my mother was diagnosed as Parkinson's disease, and then she was living in Japan, and I was in US, and I tried to teach her how to use Skype. So at the beginning, she did that, but then Parkinson, very, very quickly, within like 3 months, she started to deteriorate and it doesn't use Skype at all. And that's the time I thought, I have to develop something
So your
easy.
mother also used your system.
Yeah,
just
well,
pushing the
Skype,
button.
just Skype,
Oh,
and
just
then I
Skype.
couldn't do it. And that's the time I thought, well, if we develop a much easier one, could be a very good intervention because I could tell after talking with me, it's more, you know, delighted, and then also her cognition seems to be better. Yeah. Otherwise, she goes very dark mood, alone, and then isolated, no talking. Yeah. So talking is important.
Yeah. So So we would like to make clear how each conversation impact on ourselves in somehow like kind of measuring our weight. We can see the current weight, but current situation we cannot see right now. So if we can visualize such slight change like blood pressure, like and so cognitive functioning, but because kind of cognitive test is really a kind of rough measure. So MOCA score 26, 27, 8, 9, 10. Yeah, so of course we can say that 26 and 30 are totally different, but 36 or 27, it's a kind of perturbation.
Yeah.
And so in the morning, maybe it's 26, and so at noon, 27, and in the evening, maybe 26 or 25, and so up and down, maybe within 1 or 2 scores.
Fluctuation. So the two big challenge of dementia research is that personal fluctuation is really big. So one time, if you go and assess MMSE is 29, but then when she was assessed right after recovering from flu or cold, can be easily 26. And this four point is,
change the prior results.
Intervention efficacy is like 2 points. So this good day, bad day difference is way bigger than intervention efficacy. So that's a big challenge. But then if you have a more densely, frequently monitored scores, then precision improve, and then it's more accurate. And that's like advantage of digital biomarker, either app-based ones that you can do many times without the practice effect.
Or maybe a kind of passive one, and measuring EEG, or sometimes kind of spontaneous responses without noticing that they are
Yeah.
measured, but
Yeah,
the
yeah,
brain
yeah.
responses in
Yeah.
a certain way.
So another expertise of our team is digital biomarker. We're using wearable and step count in home monitoring, and that's really more sensitive to intervention efficacy. Because it's more frequently observed, so that we can erase this fluctuation effect. It's more trend effect.
So activity also reflects cognitive functioning. So we tried to do, but it didn't work so much.
I
In our
see.
study, just so actigraph, and so measures or calculated
see.
some, well,
Yeah. So
Okay.
the I-CONECT, we did once per week phone call, and that's every week. So it's a relatively high density data. And then we can see a low blue mood. We asked blue mood, how often did you feel blue mood last week? So we could see the changes. Gradually it's becoming better.
Oh,
like-
blue mood becomes shorter.
Mm-hmm.
Wow.
Yeah, the frequency of happening blue mood is
Oh.
getting lower
Oh.
towards the end of the intervention.
Oh, so subjectively, objectively, yeah.
Yeah.
Maybe. So, and then can they report such things? Because how many blue mood did you have in last week? And this question also a bit difficult for me.
Yeah.
How long? And,
Very subjective. So each person has a different level of, frequency. Yeah. So who never had a blue mood, one occurrence blue mood might make big thing. But those who frequently blue mood, couple more is not much difference. Yeah, so it's all individual level measurement. So the nice things about the digital biomarker is that each individual can provide so many data, so the shift can be individualized shift, which is much easier to detect.
So objective, so measurement also have some, objectively, but every time the same way they ask the same questions, and so that might fluctuate, and then it's the reality of objective feeling.
One question I have to your study is that so you recruited a volunteer, right? Do you measure their cognitive level, like MCI, mild cognitive impairment?
Yeah. So in the beginning we had no budget and no grant, and then so it's fully volunteers.
I see.
But after I came to RIKEN, and then did randomized control trial, and we pay some gratitude, and then so we of course assessed. And then almost half are MCI level from MOCA. So even though they are working somehow as a silver human resource center, but some of them have MCI.
Early MCI. Yeah. Okay. And then is that based on MOCA cut point or neurologist or psych?
Yeah, MOCA based.
Yeah,
not strict diagnosis.
I see.
So do you do strict diagnosis to identify MCI?
For our study,
I-CONECT.
because all my collaborator, is a neuropsychologist, psychiatrist, all this. So we want to make sure that MOCA can be low if they have a depression, for example. So we have to exclude all these possibilities, and is it real MCI or not? Yeah,
strict.
Neurological test.
So we did medical doctors to see the medication may affect cognitive functions, and so we excluded such people who get medication, but not strictly diagnosed. So that's also another problem, and also in general, MCI have many subtypes so in reality. So maybe we need to see. So if we want to see in detail.
That's true. Yeah. And that might affect efficacy too.
So in the future, we would like to maintain our cognitive functioning as a whole in the society, and conversation. So if the conversation style, which is effective for maintaining cognitive functions, are made clear, and then we can recommend many people to have such conversation style.
Yes. Yeah. I think so. How do we do effectively is another issue. Like we need a business model.
So you mentioned that, so the people who want to continue can participate for free right now. And then so there's a foundation and so get donation. And then so instructors are also kind of internship and for free, right?
That's right.
At this
Yeah.
time.
So we have some college, University of California, Chico, and other office branches, and then they have a public health department, and their student has to volunteer, I think 160 hours,
Oh, really?
yeah, before graduating, getting a
Wow.
degree. So they
So they
want
can
to
get
collaborate.
yeah,
Yeah, so
degree.
we have free, service. Yeah.
Oh, yeah, I think that's a very good idea, and I would like to, well, maybe use that mechanism. I mean, ask for professors in nursing, school of nursing and public health, whether they have such mechanism. Yeah, we may definitely try. But for more sustainable way, whether we can ask participants to pay some kind of resource to, so more balancing manner from private companies or the participants themselves or family of the participants, or
Yeah, that's very difficult, I think. The elderly do not have much resources
in general.
Yeah.
In the US, sometimes people have more resources to prevent, or more motivation, because the insurance system is different from Japan. And so we can get a good medication with a relatively low cost. But for US, people have to pay more insurance, or and then so they have more intensive to prevent something.
Yes, I agree. Yeah. Yeah. So we have to sell the idea to insurance company.
Yeah.
And then they can reimburse. That would be great.
Yeah. So let's try to implement as well. Yeah, as well as so maybe basic findings as well.
Yeah.
Yeah. So she's, I've heard that, so she's preparing for next trial, and for the studies to combine different behavioral
medication. Like RICEPT is very popular in US to give to even MCI. It's the RICEPT is originally targeted to early dementia, AD people, but now 50%, almost 50% of RICEPT recipients are MCI. So, but pharmacological treatment, if you just say, try this drug, it doesn't work. We need some emotional sort of support. That way we can improve adherence, medication adherence, and then boost more reactions, because human contact is very important. So we want to combine a pharmacological treatment with this more, human contact. That way it's boost medical treatment more. That's my next grant. I don't know whether it's funded or not. US, Yoko knows, NIH funding is very stingy right now. It's almost cut into half. So our proposal is being reviewed, but we don't know when we get money.
So maybe we need more kind of, different sources to, maybe. So if, as well as private company supports somehow or some part, then that would be somehow,
How's the Mihoko, your study, who is going to fund like the next stage?
Yeah, so originally we were funded by JST or JSPS or such government funding, the mainstream, and some part also private company, but it was really not so large scale. and not
see.
for trial side.
Mm.
And so our trial was basically, well, supported by this AIP center. Because AIP
Okay.
center is originally a government-funded project, rather than a kind of, well, just institute or
I
just center.
see.
Yeah,
Okay.
so yeah, the being here needs to be funded by AIP. And then we could do the RCT. But now we are not a government fund, well, somehow government funded, but more kind of part of the RIKEN, more, well, stable center. And then so we need to get more, well, diverse
I
funding
see.
source.
Yeah.
And so we are
Yeah.
also planning to have some crowdsourcing as well.
Mm.
And so we developed a movie for that purpose as well.
I see.
Yeah, with a kind of music. So
Mhm.
yeah, encouraging and
Who
to.
is watching in the YouTube, right? You uploaded to.
So this one is so before uploading. So the final movie, it's already on YouTube channel. And
Okay.
for a walk and talk program in Kishiwada City. But for 3 are, so it's actually the final stage of revision. So there is a time code there.
I see.
That's why. So after we finish editing the movie, and then we may put them on YouTube and asking for next generation robot to develop.
I see.
Yeah, combining big Bono and small Bono and maybe intermediate Bono to have, well, dialogue functioning as well as moderating functioning. Yeah, so please support us. And then so look for the sponsors
Okay.
or
Yeah.
supporters as well as more and more participants.
Same situation for us too.
Yeah, thank you very much.
Thank you.
Yeah, and thank you very much for this great opportunity to have this discussion to impact on.
It's my pleasure, and I'm very excited to learn more about your study, and then I look forward to your future studies.
Yeah, as well as our future collaboration
Yeah.
somehow. Yeah, thank you
Okay.
very much.
Thank you.
And thank you very much for participation, and so thank you very much for discussion. Thank you very much.
Thank you, everybody.